Well, now we're going to find the inverses of exponential functions. And we have found inverses before in polynomials. Certainly we have. And if you may recall, what we did is we would swap the x's and y's and then solve for y. And that's what we're going to do in this situation. So let's see what we got. We got write an equation for the inverse of the function y equals 0.5 raised to the power of x. So we're going to find the inverse, and the first step is we're going to swap x and y. So now it reads as x is equal to 0.5 raised to the power of y. Now, we're going to learn, this is actually kind of jumping ahead a little bit in a way, but we're going to learn pretty quickly that we can take the log of both sides of the equation. And because what we do to one side, we must do to the other. And so in this case, we would say, okay, well, let's take the log base 0.5 of x equals the log of 0.5 of 0.5 raised to the power of y. So we've taken the log base 0.5 of both sides of this equation. And you're going to see the reason for this a little bit later. Now, one of the properties of logarithms is when I've got this power sitting up here, with a log, I can bring it out front. And now, having done that, I've got log of base 0.5 of x equals y times the log of 0.5 of 0.5. And here's the reason why I did this. The log of 0.5 of 5 is just equal to 1. And so I'm able to cancel, taking the log of both sides, I'm able to cancel that 0 and bringing the exponent out front. It allows me to cancel that and get this just in terms of y on the right side. And when we do, we're left with y, or the log of 0.5 of x is equal to y. And if I just flip that around and rewrite it, I would say that y is equal to the log of 0.5 of x. So we have found the inverse of the exponential function y equals 0.5 of x, using techniques that we've learned before. Algebra continues on with you or without you.